Hello, CS 5590 class. My name is Jack Whitaker, and this is my research paper presentation. So, as for the paper I chose Stack Overflow Considered Harmful, the Impact of Copy and Paste on Android Application Security, and it is written by the six authors I have listed. I'm not going to try to pronounce all their names, and most of them, except for one, I believe, are out of CISPA, a cybersecurity research institute, and Saarland University in Germany. So I'll begin by kind of summing up their abstract. So um, all programmers are familiar with these programming discussion platforms. I'm sure everybody in our class has heard of Quora, Stack Overflow, Stack Exchange. When you're looking up a problem or don't know how to do something, and many of the posts on here also contain copy and paste code snippets for you to implement in your solution. And basically, this paper looks into this spread of copy and paste code snippets from Stack Overflow into people's projects, and then also how that spreads into industries, so such as the Microsoft Store, Google Play, and the App Store. So for this paper, they specifically targeted Stack Overflow and Google Play, and I questioned why they chose these two. Stack Overflow is definitely the most popular programming discussion platform. And then as for Google Play, um, I know Apple kind of has a lock on all of their own specific stuff, and then maybe Microsoft isn't as popular as Google Play. So it could be a mix of factors like popularity and accessibility to code and stuff in there. And it would be interesting to see if they could do other ones in further projects down the line. So essentially, what is happening is um, copy and paste code from. I wrote. I just realized I wrote Control P instead of Control V. Ignore that. But essentially, people are copying code and putting it into their projects, and then that spreads into Google Play and the Android store. Um, but what happens if this code that they're copying is insecure, and these insecurities will then spread into Google Play? And what they look into is if that's happening, and what are the implications of that? And then also, if stuff is spreading to Google Play, people could be taking things from other projects from the code in the Google Play Store and implementing it into even further projects, like a company using the same code for their own apps over and over and over. So it's pretty important to stop this spread of insecure code copying. So basically, what did they do? They scanned Stack Overflow for security related snippets, and I will talk about what they mean by security related later, but essentially, it's just markers of some security API usage, and they did filter that a bit too, because they don't want, you know, you just constructing something that's not really security related, but I will mention that later. And then they eventually got a list of these snippets and then searched through Google Play apps for those snippets using a variety of techniques that I will cover later. So basically, their main kind of big headline result and what they found is that 15.4% of 1.3 million Android apps contained security related snippets that they found off of Stack Overflow. And then of those apps, 97.9% contained at least one insecure statement. So this data immediately makes this article pretty intriguing and definitely caught my attention in wanting to continue to read and do my presentation on it. So, firstly, I will go into some background information. These are just some things while I was reading the paper that I wished um, that I knew more about. It would definitely make reading the paper easier and kind of helpful in understanding what they're talking about. So I will go through um, some examples of insecure code and then um, kind of intro to machine learning and how that goes into um, support vector machines, which was something that they employed, and then also program dependency graphs. And these are just some things that I didn't have enough of an understanding of at the beginning of reading this paper and had to do a little research myself. So I think it's good that I talk about these because then it'll make reading the paper much easier. And there are some other things that are harder to understand in there too, but I don't really have time to do everything. But these are the main things I think. So just for some examples of insecure code snippets, this could be in the form of requesting unnecessary permissions. So the first example that comes to my head is if you're trying to read data from a file and using in C a chmod command. Um, it would be pretty easy and careless to just every time you need permissions to just go with the um, 7 on this, put that for everything, because then you don't really have to think about what you're able to do. And this is definitely unnecessary in most cases and will lead to you giving permission to people that do not need permission, and hopefully that you don't want to have permission to things. And then another example is insecure X509 certificate validation. So if you're certifying that if someone using an application is who they are, you need to be able to do that in a very correct and secure manner so that people that you don't want to be using your app or accessing certain points need to be authenticated properly. So it's important that you do that, and people can be pretty careless with that. And then third, just some common misuse of cryptographic APIs. So if you're using hash functions or encrypting in a manner that is outdated and insecure, these are can be pretty bad and can lead to some pretty big insecurities in your code. And that is definitely something that's very common if you don't have a understanding of these algorithms, and definitely doing something for the first time, not knowing which algorithms to use and whatever. So as for machine learning, it can be broken down into unsupervised and supervised learning. And these differ in that supervised learning has a set outcome to begin with. So supervised learning, you're giving them the algorithm just a bunch of data and it's playing with it and just seeing what it can find. So I guess just correlation, seeing how it can group the data maybe. But they use a supervised approach in that if they're trying to classify some code snippets, some security related code snippets as secure or insecure, um, they will put those as the two outcomes, and the machine learning algorithm can then sort data into those two types. So that leads me into regression versus classification. Classification is the programmers are specifying classes or groups to group data in, and the regression is more like the algorithm is trying to find a number or something. So in like finance, the machine is trying to figure out how much uh, profit you would have if you did all this or whatever. But classification, you're giving it groups, and it is just simply sorting data. So those definitely differ on output type. And the goal of machine learning is to learn without being programmed or spit results without being explicitly programmed. So obviously, they get a lot of snippets, and they did have to input some training data into the algorithm, but obviously they don't want to, put everything into it because that would take way too long. So they put a little bit of data and classify that manually, and the machine learning algorithm will learn based off of this, and then be able to do that work by itself. So for this classification algorithm, they used support vector machines, and it can be used um, in regression as well, but it's most commonly used in classification. And essentially, the algorithm will organize data as points on a graph. So this algorithm is composed of support vectors, the hyperplane, and the margin. And the support vectors are basically data points that are closest to the hyperplane, which separates the two classes here. And so those are the most important points in determining where this divider will go. So just because they're the closest, they're the things from the classes that are most alike. So they obviously have some more importance. And then the hyperplane is just the space dividing this classified data. And the goal of the algorithms to maximize this plane or increase this margin, because this will result in very clear decisions with less ambiguity. And yeah, in this case, the researchers classified a bit of training data for the algorithm to create a graph off of, and then introduced new points or code snippets to see how the machine would classify it or plot it on this graph. So another thing they used later in comparing or seeing if Android apps used um, these code snippets are program dependency graphs. So they are basically directed graphs containing nodes of single line commands that you commonly see in code, and they're labeled based off of the flow of the program. So in these examples, obviously, um, creating variables and then doing things with these variables, looping around, as you can see here, and there's conditions, whatever. Um, so if you're trying to compare how similar the program dependency graphs of two larger projects are, kind of the summed up approach that they used were one can create program dependency graphs for every method in a larger project and then separate those into independent subgraphs. And then you can compare the similarity between two projects and seeing how many matching subgraphs there are between the project. And another thing they had to do with Stack Overflow is much of it are just like code snippets that won't run on its own. So they had to use some manners of converting that to a runnable code, which that's something that you can read more about in the project. It's pretty complex. So basically, their project contributions um, were the overall project process, the static code analysis techniques they used in finding the code snippets, their results, and then their automatic processing pipeline. So essentially, their whole process, they identified all Android posts on Stack Overflow, extracted all security related code snippets from those posts, then classified the security of those snippets through the machine learning approach that I went through the support vector machines. And then overall, their process allows for security related Android code snippets to be analyzed. And then to find the security code snippets, they used static code analysis techniques. So basically, they took a bunch of security related APIs and looked for markers of those and their usage. And they filtered out using different manners of, like, if there was doing a constructor, doing stuff that isn't really security related, but only related to the API. They had to filter that kind of stuff out. And then um, the results from their study, I went through the big headline, but they classify the results into the different types of security, um, like what percentage of the whole number were from hashing or TLS and whatever. And then they also fully automated their entire process for measuring the flow of security snippets from Stack Overflow to Android apps, which I will go through. So basically, their pipeline is extracting all code snippets on Stack Overflow, or all security related code snippets on Stack Overflow. I think they filtered it so they were about Android as well. And they would basically, oh yeah, filter out these security related snippets from step one to step two, and then classify these snippets as secure or insecure using the machine learning approach. That's step three. And then step four was to generate an abstract representation of each snippet. So, like I was saying, they needed to use some techniques to convert some code snippets into like runnable code that could then turn into a program dependency graph. So they did that, and then they would use the representations, so the program dependency graphs, to look for matches found in Google Play apps. So basically, that was their process. And then for some historical context, this is a relatively new issue, um, to the extent of what they did, because they do um, relate some studies that I will go through later that relate to finding insecure code. But doing a bit of digging myself, I definitely found some more recent studies and individuals addressing this issue, and they did so in slightly different contexts also, which is good for making excuse me, this network more broad, and finding out if these insecurities are found in all across all applications, not just Android. And most of these came after the original uh, paper that I'm going through in 2017. So, some similar, more recent studies. In 2018, Jeff Moss at Black Hat Europe 2018 made some comments, and another study, um, an empirical study of C++ vulnerabilities in crowdsourced code examples. That was in 2019 and revised in 2021. The study focus for the 2019 study was pretty similar, only they analyzed GitHub and C++ specific code snippets also on Stack Overflow. Um, they didn't specify if the code was insecure, but they do say it's vulnerable. So if it was vulnerable in the sense that it wouldn't work well, I don't know why they would copy it from Stack Overflow in the first place. So I guess it kind of has to be insecure. Um, And as for what Jeff Moss mentioned in his talk, was that there are lots of insecurities found in all types of code samples, even in lots of textbooks, which would have to be rewritten for a heavy cost. I think he said something like $200,000 to $300,000 in all these textbooks. Their code examples are insecure. So some of the related works that they mentioned directly in their paper were the security of mobile apps. So basically, finding vulnerabilities in Android and iOS apps in man in the middle attacks, and insecure usage of cryptographic APIs, and overall much more specific instances of insecure code in applications. They mentioned a few studies about that, and then studies about developers themselves. And some other studies suggested that the bulk of security issues came from poorly skilled and inexperienced developers. And then much of these studies were focused on, I believe, TLS code and a bunch of things that developers were unsure about when they answered about stuff that was answered on Stack Overflow. And of course, yeah, when developers they're unsure, they ask Stack Overflow, and obviously this paper shows the problem with that. And also investigation of Stack Overflow. Speaking of that, there were some more studies they mentioned about Stack Overflow and the trends in usage when APIs update. There'd be more questions asked about them on Stack Overflow, and also how Stack and Overflow and GitHub interact and correlate. So that's pretty interesting. And also the detection of code reusage in apps, which is basically other means of comparing large projects other than the approach they used, such as using program dependency graphs in a different manner or using control flow graphs and different ways of organizing bytecode, which is how they converted not runnable snippets. And one of the approaches with kgram streams. So just a bunch of different approaches to what they did, and a bunch of stuff related to what they did. So before this came out, but obviously none of these were really done to the extent that this study was, but they're still very interesting and totally relate to the issue. So some further implications is what I ask you is, could this be used for other things other than code? So for things such as ChatGPT, Chegg, or Spark Notes, could we scan websites like Chegg or Spark Notes for examples of a class's writing or homework problems? And I think that's definitely something worth looking at if you're this group, and they could definitely make a lot of money if they found out how to do that. And with the rise of AI, could markers of Chat GPT be recognized and listed like code snippets are, what they do in this project? So, and I know some things already have the ability to do this, but I don't know how well they're documented. And they have the ability to find lots of snippets as they show in the results of this project. But the question for the group now is what should they do about it? Because really all they do is point out a bunch of things, but they don't actually solve it in this paper. But they do mention some things about it. So, um, as for some proposed changes to Stack Overflow is obviously very beneficial in many ways towards programmers, but this study definitely demonstrates some of its flaws. So it is worth questioning if there is a way to limit that. And currently, Stack Overflow replies can be up or down voted based on how helpful it is, but most users aren't basing this rating off of security or even thinking of that as a factor. It's mostly just if their answer was helpful and helped them solve um, their issue. And the question is, could Stack Overflow implement some of this technology used in the paper to also provide a security score on snippets of code to alert users of insecurities? And they also mentioned that the creation of a browser plugin, so all code snippets could be scored using their technology, and that would make this technology not limited to Stack Overflow. And again, this is another follow-up project on the work done so far for the group. So to summarize everything, their main headline stat: about 15% of 1.3 million Android applications contain snippets of unsecure. Sorry, I thought I had a spelling error there. Unsecure code from Stack Overflow, which was done through the creation of their pipeline that scanned through Stack Overflow, created snippets of security related code, determined the level of security of those snippets, and searched through the Google Play Store for them. And their paper brings up many ethical questions relating to copy and pasting code and programming discussion sites like Stack Overflow. And again, this was only an overview and background of the paper. They definitely go much more in depth of things that I talked about. And I've attached a link in my works cited if you care to read the paper. I don't know if you'll have access to the PDF, but if you searched up the title, you'll find it. And much more analysis and explanation can be found in the paper. And it's definitely a pretty interesting read, and will teach you about maybe some new techniques of doing things that you might not have seen. So, and here's my works cited. I put most of the articles I used in here. So, thank you for listening to my presentation. If you listen to the entire thing, and hope you read the study. It's very interesting. Thanks.